about now is the making of Origination. So you got a chance to see it, and a lot of people have questions about how I made it. And it was a complete collaboration. Could not have done this by myself. Just like the workshop, you can see how many people are involved, the physicists coming in and working with CERN and so forth. So I want to kind of take you now into more of the art process behind the piece. You're going to see some studies, and you're going to see the people that were involved. So first I had this idea that I wanted to create a piece for the Havana Biennale, and I had gotten an opportunity to do a residency at CERN, and I knew I wanted it to be about particle physics. And just so you can see, like, the very first drawings, and then what came out of it. So at first it starts with the hand, and just kind of trying to figure out what the forms were going to be. Then I went to CERN, and had 2 weeks of, basically people asked what I did there, and I was, every day, Dr. Stephen Goldfarb, who I also want to thank. He's my mentor at CERN. He works at the Atlas Outreach. It's called the Atlas Experiment. The kids mentioned that there was a detector. You saw this big camera, and that's what actually takes those pictures that you saw. There are 4 of them at 4 points in that tube that's underground, and they're like a big camera obscura, if you could imagine. That's the closest metaphor or association that I could think of. Big camera obscura, and it takes pictures, and basically he works at the Atlas detector, and he is my mentor. So I went there, and for 2 weeks, every day he had 3 or 4 coffee chats with physicists, and literally we met in the cafeteria and we talked, and for about half an hour. And so it's hard to imagine, so I actually recorded one. So I have here, I'm going to play a recording with Dr. Michael Doser. He's working on antimatter, which when I arrived I knew nothing about. And that was really interesting. What I did is for every scientist I asked the same question. Like, can you explain the Higgs field? Can you explain the Higgs boson? Can you explain E equals mc squared? Can you explain, ask the same questions but from like 25 different people? And so here's his explanation.
What the Higgs field does, from what I understand, because I'm not working in that area of physics, is that all of a sudden you break the symmetry of all these basically massless particles that are flying around, and you transform them through their interaction with the Higgs field into particles that have mass. This is a sort of an arbitrary direction, arbitrary distribution of masses, because you don't know which particular direction the Higgs field will take, but that's what happens at that moment. So E is equal to mc squared just says that you can transform one into the other, energy into mass, mass into energy. So it's sort of like exchanging dollars against Swiss francs. There's an exchange rate, which is the speed of light, and you have to obey a certain number of conservation laws, like conservation of charge, conservation of baryon number, conservation of lepton number. So what this says is that you can sort of condense energy in a very localized manner, and when you condense the energy that way, out pop a pair of particle and antiparticle. Symmetric, they have opposite charges, they have opposite baryon numbers, they have opposite lepton number. They are mirror images of each other.
That's me asking the questions.
No, that's actually a misconception. E is equal to mc squared happens all the time, including in a chemical reaction. Including at low energies. You don't need the speed of light for this to happen. You really need a process that will transform a system from one state into another. So if I transform, for example, a neutron is not moving at the speed of light, it's just sort of sitting there. It can decay into a proton, an electron, and a neutrino, and in that process will liberate a bit of energy. This is a process that does the E is equal to mc squared in a way. You can run it the other way around. You can shoot 2 photons at each other at the speed of light. Yes, that's possible. But I can also put an electron and a positron in contact next to each other at very low temperatures, at a microkelvin even if I wanted to. They will annihilate and they will transform their mass into energy. And that energy can then transform back into a particle, antiparticle, or into 2 photons. So it's
Okay, that's what I was listening to. and this is my first physicist was someone who decided to really get into formulas. Yeah, talk about if I didn't get scared by that point. These were some of my notes, but after that it got easier. Most people didn't take the time to like really explain it mathematically. It was really great, actually. It got some great sketches out of it. But then after that it got more conversational. So then I put together an idea folder while I was at CERN, so you can kind of see, right, what you saw there. So I discovered the Voronoi mathematical structure that is used a lot in science. Remember the magnetic fields I told you about? Those are the vectors. That's actually a computer program code that's used. And so basically I brought this information to Marcel. Marcel Schwidlich is the coder, and the way I work with him is I bring these ideas and then he finds a way to realize it through the code. So I have to be as thorough as possible in trying to find examples, drawings, that he then uses as a reference. So he lives in Berlin, just like Robert does, and I basically looked for them in Berlin because I knew I was going to be there right before the Havana Biennale, so I said, why not find my programmer over there? And that's how we work together and why we work together in Berlin. So some examples, this is how we work. I have the storyboarding like the kids talked about. That's what I do as well. I storyboarded the whole thing, and then he tells me what's possible and not possible. So I told you about Act 1, right after the Big Bang in the Higgs field. So here's an example of a sketch that I did digitally on a monitor, the touchscreen monitor. So I give him these drawings, and then he comes back, I did this one as well, I distorted it. And then he did the Voronoi, and then I brought it back and manipulated some more. We go back and forth like that, where I'll do a drawing and manipulate it digitally or just scan in the drawing, then he'll create something in code, and I see, a little more of this, a little more watery, or a little more whatever, and then he goes back and makes it happen. So particle acquiring mass, Act 2. This was the early code. Here you can see the Voronoi. So Voronoi is the structure on the first scene with all the dots. There's actually a mathematical formula that tells the computer, make a point and then make the next one an equidistant and the next one an equidistant and the next one an equidistant. That's the rule, the instruction that it's given. And it creates this kind of honeycomb, like if you were to take away those dots and just make the Voronoi diagram visible, you'd see like a honeycomb shape, like the ones that I showed you before actually, the drawings. So this was the first attempt at a Voronoi with things growing inside of it. Here you can see a little bit of the code. So Act 3 was, remember the molecular, biomolecular, cellular? So these are some of the early sketches. I played around with dotted lines. I always like dotted lines, and I try to get them in everywhere, but they didn't always work, so I have some studies of them. So here you can really see, this was one of the first drawings that I showed you, remember, in the very first slide? That's one that I took into the computer and made it, inverted it. So sometimes I would take the drawings and digitize them just so it'd be a little more similar to what he was working with, his language. And he created that effect. And look at the final one. You can see the feel is there. He did an amazing job. And he's an artist, of course, so it's his own interpretation that he brings to it as well. It's not just that he's trying to make it look like what I want. He also brings his own experience to the table. And then there was designing the interactivity with the Earth field. And that was something that I decided that I wanted because I was doing this piece, remember, for the Havana Biennale. And the previous art piece that I did was the X trees. And the way you interacted with it was with texting, tweets, devices. And in Havana, you don't have that technology there. And it's very hard to get internet. So I said, what's going to be my way of interacting with the piece? And I really wanted to, like bring a little bit of what Cuba is. So I wanted it to be black and white, if you're asking why I went with black and white. And then I thought of interacting with rocks, which is what you saw. And again, for all the reasons I explained above, which is that this kind of also acknowledges different ways of knowing, that there are other ways of arriving at the truth. And I also wanted to explore how our sounds and thoughts and feelings influence reality and how we perceive. So that was why I created that form of interactivity through sound. In Cuba, I had more rocks, and I drew the chalk line and so forth, so there are different ways. Every time I show it, it's a little bit different. Then I came back to Taos, and that's when I came up with the idea of the slits. In Cuba, I cut them like this, you know, and I had a fan in the room because it was a big black box and it was so hot in there. But then the fan was moving the fabric, and it looked so interesting, I left it. So the one in Cuba, it actually had some movement in the fabric. And the one here was, I decided not to repeat it. It just felt more Japanese to me. It felt more clean. And I went with the space, and I brought in that whole feel. So here we are, that's Marcel and I, and that's projecting the test onto the room. You see we had a lot of rocks too. There's Marcel. It was hot there. Everybody was, Havana. It was fun.
When was this?
This was May last year for the Havana Biennale. So every 2 years, Havana has a very important show, which is like the Venice Biennale, but they feature artists from Africa and all of South America, Latin America, that don't usually get representation, so it's a very different kind of biennale. Highly recommend to go to Cuba during that time. The whole city is alive, it's in the streets, and it's a great time to go. So just so you can see the difference, see how it's cut? It was also a big black box, so you walked in, it was immersion, like real immersion. You had to take a few minutes to adjust to the light because you couldn't even see anything. So pros is that, imagine that piece with full darkness, it was really immersive. Cons is that, you know, it was really dark, so you couldn't see anything else. And this, I wanted to do it different this time, I wanted to see, and I like that it's more open, but it loses a little bit of that immersive experience that can be achieved with this piece. All right, now bear with me while I call Robert. I'm just going to play. This is, so NASA, as I mentioned, has released sounds of what Saturn sounds like, planets, black holes, and these are an example of some of the sounds that we used. So now here comes Robert.
Hello.
Hey. This is Robert. Hi, Robert. Can you see everybody?
Actually, no, I can just see myself right now.
Okay. Can you see everybody?
Oh, hi everybody in New Mexico. Are you?
Yes.
All right.
So go ahead and introduce yourself, Robert. Tell us a little bit about yourself and how you were involved in this project. They already saw the installation, so they know about it. So
Okay.
Go ahead, we're listening.
Well, my name is Robert Schirmer, last name, and I'm a musician and a sound designer, which is kind of like the mixture between being a musician and a sound technician, I would say. And yeah, I got invited by Agnes to be part of the project. I think mostly on the grounds of some other works I've done with theater, like a machine theater piece I was working with.
So Robert, I'm going to go ahead and play some of the clips that you created so that you can talk a little bit about some of them, because people have a lot of questions about where these sounds came from. So, like for example, NASA, that was from the NASA folder. Can you talk about how you created that? Or how you integrated that?
I didn't create that sound, of course.
No,
As far as I remember, it's a recording of the actual Earth's chords. And I use it, actually I did not create it, but I used parts of the sound for the introduction of the whole piece.
Thank you, Robert, and thanks for a wonderful piece. See you in Berlin.
See you, brother. Ciao.